This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Algebra 1B, Learning Target number 1. I can determine if a relation is a function. When we're talking about a relation, we're talking about two number sets, and one set gets mapped to the other. It's what is the value of y for each value of x. And remember, x goes across this way. Here's your x column. And y goes vertically up and down. And here's your y column here. Now, in order for a relationship to have this special term, which we call function, that means for each x, there needs to be only one y that maps to it. So I'm going to write for each x, there is only one y value. That makes the relationship predictable. If you know what x is, you can tell me what y is going to be. And there's no question of, well, it could be this or it could be that. So let's test to see, using a graph, if we can tell if this red line here represents a function or not. All I need to do is find one value of x that has more than one value for y. So as soon as I find one that doesn't work, then automatically I can say, nope, that is not a function. So take a look here. Let's see, I'm going to pick a number here. Let's pick this number. This point right here would be 1, 2, 3. That's 4 for x. Right there. Let's see what we can get for y. All right, and there's a point up here. That is the point 4 and 2. But notice, when I choose x to be 4, I could have gone up to hit the line, but look, I could have gone down to hit the line as well. That is the point for -2. In this case, there exists at least one value of x where you get more than one choice for y. In fact, there's tons of different x's that have two choices for y and not just one. See up here, if you go to 5, I've got an upper value and a lower value. If I go over here to 7, I've got an upper value and a lower. Gosh, I can just scan this whole section here and notice that I have two values all the way. We call this method the vertical line method. If you are able to draw on your graph any vertical line, I know mine look kind of terrible, not totally straight, but if you were to draw any vertical line and it hits the graph in more than one spot, then automatically you are saying no. This is not a function. So I would explain no by saying something like there is an x value, and in this case we chose 4. You could have had many different options to choose from here, with more than one value for y. And that would be 2 or -2. That is a really great explanation. And you could have you didn't just have to choose that one, I just chose it. You could have chosen 2 or 1 or so many here that disprove that this is a function. So if you are able to draw any vertical line here that will hit the graph in more than one spot, then automatically, no, that is not a function. If you cannot draw a vertical line and it will not hit the graph at more than one spot, then you can say, yes, that is a function. So far, that one doesn't pass. Let's check here on a table. Now on this table of values, we don't exactly know everything of what this function looks like. Maybe these are just some discrete points out of many, or maybe that's the entire function. But what we're looking for again is to check each value of x and make sure that each has only one y. So looking here first at the -3, its value for y is 0. Is there a -3 that has any other value? Nope, I don't even see any more -3s on here at all. I guess all the -3s must map to 0. Let's try the next one down, -1. -1s should only map to -1. Let's see, do I have any other -1s here to check? Nope, I don't. So in this case, -1 always maps to one answer, that's -1. 0 maps to 0. There's no other zeros here to check. 2 maps to -2. 3 maps to 4. I don't even have any duplicate numbers in my x to see if they get different values of y. So in this case, each value of x has only one corresponding y value. That is a yes. This is a function because each value of x has only one corresponding value for y. In this case, you have to check all of them. In order to say yes, it has to work in the entire table. But if you were to say no, then there is at least one case where there's an x that has multiple y answers. So for each x, there is only one y. That is how you can tell if a relation is a quote-unquote function.